Let us solve the exercise number 7 in the part B of our programming lab. In this exercise, the question is as follows. Following are the scores of maximum vertical jump before and after training program. Test whether the training program was helpful to the student. And they have also said that use the paired test. So what has happened over here is they have taken 20 students and they have calculated the maximum vertical jump before giving the training and after the students got the training. So the same students before the training and after the training, the maximum vertical jump were calculated. And what they have said is so they wanted to know whether after giving the training whether the students vertical, that is maximum vertical jump, has it increased or has it remained the same. So whether the training that was given to the student, whether it was any help to them or it has not helped them in getting the maximum vertical jump. So this is what is the question. Now how do we calculate this? So definitely we have the pair here, that is the before the training and after the training. That means to say that there is a paired values and we are supposed to find whether their mean, there is a significance difference in their mean differences. So naturally we have to go for a t-test and I'm going to solve the manual value first and then we will go to the R programming, because in R programming you don't have to do much there because R is going to give you the answer straightforward. So let's try to solve it manually. So what are the things that are given over here? So the students are there, 20 students are there, and their vertical jump before the training and their vertical jump after the training is given. And what is that they have asked is whether the training is of help to the student or not. There are two possibilities now. Our null hypothesis will be the training program was not helpful. And what does this mean is that the before the training and after the training there is no significance difference in the maximum vertical jump. Now for those who have not understood the problem, don't look at these values and say that see the before the training it was 24 and after the training this before the training it is 22, after the training it has become 24, so there is an increase. We are not talking about individual one. This is the sample that is given to us. There are many other students, so out of so many students, 20 students were selected and they have measured it for the 20 students. Now they expect us to say whether for all the students whose names or whose numbers are not here, whether it is significant to even to them or not. Okay, so they are talking about the whole population altogether. And what is given over here is the sample. So now what they are expecting us to say is whether the before training and after training, is there a significance difference in the maximum vertical jump. So we have two hypotheses here. One is the mean before the training and the mean after the training are same. That means there is no significance difference. So this is the null hypothesis. And what is the meaning of saying no significance difference? The training was not helpful. The students maximum vertical jump did not changed at all. The other alternative hypothesis is that the training program was helpful and that the students were able to jump higher distance as compared to the distances that were covered by the student before the training. So the training, the mean for the maximum vertical jump before the training is less than the mean maximum vertical jump after training. So that means to say that after training the mean value has increased. So this is what we are supposed to do it. Now you notice over here that we have the less than here. So that is the mean value before training is less than mean value after training. That means to say that we are going to get the one-sided trail here, and that means to say that it is going to be a left hand side, or it's going to be a negative value. It's going to come on the left hand side. So what do I mean by saying that is, see, when you have generally two options will be there. So you have see this one, mu1, that is mean before training and after training are equal. This is the null hypothesis. The other possible the alternative hypothesis is mu1 is not equal to mu2. So it may be less or it may be more, but it is not equal to mu2. So when you say mu1 is not equal to mu2, what you are going to get is it may come on the left hand side, or it may come on the right hand side. So you get a two-tailed test. Now the other possibility is, in the situation, in many other situation, you may like the one that is over here, the mu1 is less than mu2. That means it is going to come on the left hand side. So you're going to get the one-sided tail, that is it's going to come on the left hand side. This is the middle one is the 0. If mu1 is greater than mu2, it's going to come on the right hand side. So you may get the value left side, right side, or on the both the sides. That is you may be performing either two-tailed test or one-tailed test. In our case, we are going to perform the one-tailed test because it is less than the value that is given over here. So what is the thing that we are supposed to do it? So the two maximum jumps were given before the training and after the training. As usual, you find the difference between them. So before the training and after the training, find the difference. So 22 minus 24 is minus 2, and 20 minus 22 is minus 2, 19 minus 19 is 0, 24 minus 22, and so on. So calculate all the differences and then find the square. Minus 2 square is 4, minus 2 square is 4, 0 square is 0, and so on. 2 square is 4, minus 3 square is 9. So you first find the difference between this part and the other part. You find the difference, that is d, and then find the d square. After that, you sum all these values, minus 2 plus minus 2 plus 0 plus 2 plus minus 3, and so on. You find their sum. You're going to get the sum as minus 19. Similarly, find the sum of the square, that is 4 plus 4 plus 0 plus 4 plus 9 plus, and so on. You find the sum. You're going to get the value 51. Now we are supposed to find the mean differences. So we have this one as the difference here, difference between them, and we have the sum of all the differences. Find the mean. How do you find the mean? Sum of all of them, that is minus 19, divided by total number of students, so that is the total number of players, which are 20. So divided by 20, you're going to get, remember this is minus, so you're going to get minus 9.5. That is what I told you. You are going to get it on this minus sign, that is on the left hand side. You're going to get the value on the left hand side. So it's going to be a negative value here. Now what we got is the sample mean difference. So let us now find the sample standard deviation of differences. So we have got the mean differences here. Now let us try to find the sample standard deviation of the mean differences. So sorry, the standard deviation of the differences. So how do you find it? Standard deviation ST is equal to the summation d squared by n divided by summation d by n whole square, that is summation d square. You already have it over here. So we have found the d square here. We have found the d square. We have found the summation 51 divided by n, which you know very well. N is 20 number of students are there, and this value you have already calculated, that is summation d by n, that is 0.95, which is already calculated. So substitute 51 by 20 minus 19 by 20 whole square, that is we have already calculated, minus 90 by 20 is 0.95 square. So find the square of that thing and subtract it, and then find the square root of it. So you are going to get the value as 1.2835 as your value of the sample standard deviation of differences. Now let us try to find the pair test, that is the t-test. So the formula for t-test is the mean sample differences, that is sample mean differences, divided by the standard deviation, that is standard deviation of the differences, divided by the square root of number of samples which you have, that is 20. So you substitute the value here, the percentage d is been taken over here, the standard deviation of the differences are being taken over here, and number of pairs, that is the samples that we are talking about, is being given. So what is this uh, d bar is the mean, that is sample mean difference, which is already calculated, sample mean difference we have calculated. And then we have the next one, st. St is nothing but the sample standard deviation of differences, and the square root of n, which is not n is nothing but number of pairs. This term what you see over here, that is this term, the st, sample standard deviation differences divided by the number of pairs, this term is called as a standard error. So what is the significance of this? It is going to estimate how much the sample mean difference, that is this percentage d, is expected to vary from the true population. Remember, we have taken the samples here, samples of 20 students. So this is the sample of 20 students, but there are many other students are there. We have just taken only 20 students here. Now this estimate is going to give you how much is the difference between the deviation here and the original full sample which is there outside, which contains many values. What is the difference? So it's going to give you the, this is called as the standard error. So it's going to give you how much the sample mean the sample mean difference is supposed to is expected to be vary from the true population. Okay, so let us substitute. We have the value as d bar is point minus 0.95, and standard deviation 1.25 and 20. You just substitute all of them and you do the calculation as usual. So use your calculator or Windows calculator to perform this. So you are going to get the value as minus 3.284. So this is the value, you got it. This is from your calculation. So when you calculate it, you are going to get the t value as this one. Now we assume that even though they have not given the level of significance in their uh, question, they have not given the level of significance. Generally, whenever the level of significance is not given, we expect 95% of the value, that is the 5% of significance. 5% means, to say that 95%, more than 95%, are you confident about the 95%? So this is we are going to test for 5%, that is the 5% level of significance. So how do you calculate that thing? So we take the number of pairs, that is n samples where 20 were there, minus 1. So you are going to get 20 minus 1, and this is the degree of freedom. So you got the degree of freedom as 19 here. So the total number of samples which were given here was 20. You know very well, 20 players were there. So 20 minus 1 will give you degree of freedom. So you are calculating the degree of freedom here, which is 19, and we want to test for 5% of level of significance. That means to say that we want to say whether are we confident, 95% are you confident that there is no significance difference in the performance of the student before training and after training. So we want to test that thing. How do you do that thing? So the university has given you this t-test. So I'm going to use the same one, even though it is Xerox, and you feel you see that a lot of thing is there, but I'm going to use the same thing. Your college will give you different one with the colorful one. That's a colorful one, but the neat values may be provided to you. So let us go here, and we were talking about 5% of significance. You notice that there are two values are here. This is one-tailed and the other one is the two-tailed. So you notice here, that is what I told you. You get two-tailed value or one-tailed. Remember, don't worry about whether it is a right-tailed or left-tailed. the only thing is when it comes to the left it's going to be minus value. When it is on the right hand side it's going to be a positive value. That's it. Don't just bother about that left or right. Put minus sign, that's it at the end. So let's go to this 19% value. So for 5% significance, let us go to the 19% value over here. The value that we are going to get is 1.73. So this is the value that we are going to get it. And you notice that we are talking about the left hand side tail here. So we are going to put the value as minus 1.73, even though we got the value here as 1.73, because it is a left tail, we are going to put as a minus 1.73. So what you notice, so the t value here is lying on the rejection rate. This value, you notice that the critical value is 1.73, and this is far away from the value over here. So this is very far away from the 1.73 value. So we say that since t value lies, it's going to go beyond that value, that is 3.17. So we say that we are going to reject the null hypothesis. The reason for that is that this critical value is far less from the one that we are trying to this value 1.73 is more than what you notice over here. So we say that we are rejecting the null hypothesis, and we say that the training program was helpful to the student. So this is what we are supposed to say. Now let us go and let us do the calculation in R. So I'm going to go to the R here, and what are the things that we are supposed to do? Just go here and open a new script. If you are not already opened, open a new script, and we whatever values which are given over here, so these values which are given here in your question, convert them into the vectors, and then let us create a data frame for that. I have taken the liberty of typing them, these values. So this is 22 comma 20 comma and so on so forth. I've taken that liberty, and I have already kept these values here directly. So you do it manually. So 22 comma 20, you notice, comma 19 comma 24. This is going to take a lot of time, so I have reduced the video size by just taking these values and directly typing here. So these values whatever they have given, 22 comma 20 comma 19, similarly 24 comma 22 comma 19, that values whatever is there, I have already copied them. So and created a vector out of this. Let me just run it, and I got the vector here, and the next value also I'm going to create a vector here. So before and after. Before is before the training, and after is after the training. Let us create a data frame for these two values. So how do you create the data frame? I'm going to call this one as a data. So I will say, let's say data is nothing but the data dot frame, and I'm going to put these two values before and after. So let's create that one. So we have the data frame ready with us. So let me just run it, and you have the data frame with these two values. And now let us perform the p-test. I will store it in a variable called as pt. And how do you do that thing? You say t dot test. We are performing t-test, and we are supposed to give the two values. Data is our value that we have it over here, and you know very well data has a meaning of the before and after that. I want the before value, so I put a dollar and before. I put enter there, and again data, data and dollar and after. Select it and press enter. Remember, we are performing the pair test. That is what is also mentioned in the question. Use the pair test. So let us use that also. So I'm going to say paired is true. Okay, so that's it, paired is true. And let's run this one. So we have executed it, pair test. Let me just type what is it going to show, pt, and just press enter. Sorry, not enter, just run it. Not pressing enter will not help you. So this is what you are going to get it. So what are the things that you are going to get here? So what is the interpretation? First one is the t-test that you have performed. Even though the value that we got here in our calculation, let's look at our value. Our value is 3.2 something, 3.28 something, but what they have got in R is minus 3.2262. So they got a slightly good value because remember they are making use of a very high precision. We have I've reduced some decimal points there, so and I kept it only two decimal places. So my there may be some small errors in my calculation. So what is this t indicates? This is the one that we have done, that t statistics. Okay, this value measures the difference between the observed sample means and the hypothesized population means. What is meaning of that is what's the difference between the observed one and the entire population. So the sample that was given to us, and we have calculated all the values. 20 students details were given to us, that is the 20 students the test values were given to us, and we want to compare it with the entire population. That is what is given over here. Now one thing you must notice is that if this value is larger, so what does the it means? So take the absolute value, not the minus. Don't get carried away by the negative values over here. So don't get carried by that negative is because it's the left hand side the test, that's it. Okay, it's not something that has to be considered like that. You just take the absolute value without the minus sign, you take this. So if this value happens to be larger, that is the absolute value is large, what is the meaning of it? So it means to say that there is a greater difference between the observed value and the null hypothesis. So what is our null hypothesis? The null hypothesis says that there is no difference whether you give the training to the student or not, they will not jump any further. So their jump, what the values that are given over here before the training, their maximum vertical jump, and after training there is no difference at all. Your training is useless. So that is the null hypothesis. But the value, when you get a very high value over here, where is it gone? When you get the high value over here, it just means to say that there is this value is deviating higher from the your null hypothesis. It is moving away from your null hypothesis. Next one is the degree of freedom. You know very well, degree of freedom is the total number of pairs minus 1. Okay, so the total number is 20. 20 minus 1 is 90. Next one is the p value. So what is this p value? So p value, this is going to be the most critical value that will determine everything. So what it says, it is the probability of observing data as extreme to the sample data. That is that means to say that what is the meaning of saying that probability of p is the probability, uh, whether there is a probability of improvement or not. Okay, so if you take it let's say our significance level of significance is 5%. That is we are saying that we want to be 95% confident that our values are our results are proper. So if you observe the p value, so this p value whatever you observe, and what is our level of confidence that we had 0.05. So this is 5%. 5% is 0.05, not 5. 0.5 means 50%. Don't get carried away by this one now. This is 50%. 0.05 means 5%. Compare it with this value. So what is this value? What is our p calculated? The p value with respect to the significance. This is we call it as alpha. With respect to this alpha. Okay. this value is very less, that means to say that you're going to reject the null hypothesis. Okay, so it simply says that there is statistically there is a higher significance. Okay, so it see why do we do that thing? So so some of you, if you're not getting it, see the thing is, you may get this value because of a chance. See, you took random values. You didn't took all the values of the population. You took some values. Some you called it 20 students. You come here, you jump, and you measured it. See, for your bad luck, it may so happen that you selected all the good students, or you selected all the bad students. When I say good and bad means all the students who can jump very far away, or all the students who cannot jump far away. The thing is, you are calculating the samples here. All your calculations are with respect to the sample. Now, these samples may be good, bad, or worst, or anything. But you want to see whether the entire population which was there, whether this is making, you are predicting the value of the entire population now with respect to that sample. Okay, so our null hypothesis says that there is nothing, you give training or not, nothing is going to change. But what happened with respect to the our the value that we got, we are saying that you give the value 95%, you must be very sure. That means level of significance is 5%. You say whether are you 95% sure that the training has helped the student or not. Now we are saying that look at this value, p value, which is less than our significance value, so we will reject the null hypothesis and say that this training has helped the student, and it has improved their performance. Now what if this value, suppose if this value was greater than the 0.05, definitely then we will say that we will not be able to say that the student the training has helped the student or not. So we will fail to reject the null hypothesis. So that is the meaning of it. Okay, so this is with respect to the confidence level. Then you know very well, we are, I have already told you, we are going for 95% of confidence level. That means to say that we are talking about 5% significance, and then you have at this these two values, so that uh, what is the meaning of those two values. See, this values, two values will uh, if it contains the value 0 in between, suppose I'm just giving you this value. So okay, let's uh, say something like point say minus 4.5. I am just giving you some value, and 5. So this minus 4.5 and 5, see, remember, so if you take the scale here, okay, this is a minus 4.5, and you know very well 5 is then you have minus 3, minus 2, minus and then you get 0, 1, 2, 3, 4, 5. So you get the value 5 here. So this range contains 0. If it contains 0, okay, okay, so if it has the value 0, then we are failing to reject the null hypothesis. So that you just look at this value. Where is this value? If it contains 0 in between, if this range contains 0, for example, you may get the value as 0.4, and the next, oh, sorry, this minus, say, minus 0.4, and the other value is again plus 4. So remember, between minus 0.4 and plus point, there is 0. If it contains 0, then you say that you cannot reject the null hypothesis. If it does not contain the 0, in this case, you notice that both the values are negative. What is the meaning of this? In your scale, this is minus 1.5. Okay, this is minus 1.5, this first value, and minus 0.03. Where is the 0? 0 is here. This is this range does not contain 0. So we say that we will reject the null hypothesis, and this value, the last value, you know very well, this is the mean difference, and this is what we have already calculated. Mean difference, the first thing that we did was we calculated the mean difference, we calculated the difference here, and we calculated the mean difference. So that's the mean difference that it is going to give. Now our answer is not complete. Okay, so we have to say whether we are rejecting the training or not. So from the value we are going to take this. Remember I told you that p value, we are going to take that p value, and we are going to say whether this value, that is within that p, whether this pt value, whether if it is less than 0.05, then we say that we are rejecting the null hypothesis, or we say that we are accepting the null hypothesis. So let's do that part here. Where is the mouse pointer? I'm not getting my, okay, it's here. Okay, I'm going to say if, okay, let me just put some space there. If, so this is our pt. Okay, pt is this variable, you know that. Okay, this is the pt variable, and this pt will contain a lot of things. So we say pt dollar, okay, okay, p dot value, p dot value, you see whether that value will appear or not. Let me just show you that value here, whether it's going to appear here or not. Just run it. Okay, this value. So you know, notice that p dot value is this value that I am talking about, p dot value. So this value. So if this value that I have already told you, if this value is less than 0.05, we will reject it. So this is what I'm going to do it in programming. That's it. So if this value is less than 0.05, this is my level of significance that I have taken. So this is my level of significance that I have taken. Then I'm going to print, you can say print or cat, whatever you use it, whichever value you want it. You say that training, if it is there, you reject it. Training program was helpful, because in that case we are saying that program was is helpful, okay, to student. So we know that we are rejecting the null hypothesis, in other words. Okay, in plain English we are rejecting the null hypothesis. Let me just put flower bracket, not really required, but just for the sake of uh, writing it beautifully, I'm going to just do that part. Else we will I will not type it again. So I will not say that training program was okay, is not helpful to the students. Is it correct? Is not helpful to the student. So these two values you are going to take it, and just I'm going to select it, and I'm going to run it. Okay, training program was helpful to the student. We are rejecting the null hypothesis, and we are saying that training student, the program was helpful to the student. This is what you are supposed to do it. Write this part during the examination, and this is your which is R part, and the other part you have to solve it manually using pen and paper. So for both of them the marks are there. Please look at the marks that they are providing. Let me just show you the question here. So the marks that they have provided is writing the R script, your marks will be 4 marks. Solving it manually, you get 8 marks for that. Totally you are going to get 12 marks. That's all. Thank you for your interest. We will meet again in the other exercise. Thank you.